Hello everyone. This video will be on the 3.14 section of the IBAA curriculum. Please pause the video for a second to look at the concepts, contents, and formulae for this section. One sentence that summarizes this section is, combine two vectors to get a line. Alright, so remember from the previous videos we have learned about the vectors and the vector additions as well as scalar products. So now we're going to use these vectors to create a new concept, or well, connect to our existing concept, the line. Vector, while it has directions and magnitude, it has no position, right? Well, a line could have a position, but it won't have the magnitude. Let's first see how we construct a line. The vector equation of a line can be given as dr equals a plus lambda b. At this point, we need to know exactly what that means. So let's talk about the meaning of each letter. So in this case, r represents the whole equation for the line. It's not a vector, but it's just a point. A is a vector, and specifically it's called a position vector. It kind of sets up the line at a position. Lambda is a scalar value, also called a parameter. It doesn't have too much meaning at the moment, but we could put any values here and come up with the exact point. B is the direction vector, one of the main characters here. It sets the direction or the pathway of the line. Can you see the connection to our prior topics? The hint is in the name, the vector equation of the line. The linear equations in topic 2. The form looks very similar to that of the gradient intercept form where we write y equals mx plus b. With the gradient as a direction vector, x as the parameter, y-intercept as the position vector. So I could rewrite this as something like c equals xm. And you can see the connection, r equals a plus lambda b. They're extremely similar, so perhaps you can remember this that way. Now, the second formula is a mere expansion of the first one, since we can rewrite the first equation using vector notations. Let's take an example. Take a look at that. Let's say we have our r equals a. Let's say it's like 1, 2, 0. And then lambda, and then b is another vector, the direction vector. Let's say negative 2, 1, and 3. Okay. Then the parametric form of the equation of the line is we're going to look at each component. Okay, so we can rewrite this as x equals 1 plus 2 of negative 2, 1 plus lambda negative 2, and y equals 2 plus lambda 1, and z equals 0 plus lambda 3. Or we can just rewrite it as 1 minus 2 lambda, 2 plus lambda, and 3 lambda. Okay. However, the name is important to note. It's called the parametric form. This way we can specify the parameter that we're interested in, x, y, or z. And notice how the lambda is used again here. Lastly, the Cartesian equations are an extension of the parametric form, and that they all isolated the lambda. Okay, so if I rewrite these equations, then I can go x minus 1 over negative 2 equals lambda, and it'll be y minus 2 equals lambda, and it'll be z over 3 equals lambda. So then I can conclude x minus 1 over negative 2 equals y minus 2 equals z over 3. So that's my Cartesian equations of the line. In the IB exam, you may be given the equations of a line in any form, so be prepared to deal with all of these forms. Let's try some questions, shall we? Consider the 3 points A, B, and C, where A is given as 5, negative 3, and 2. B is given as 9, negative 10, and negative 13. Oh, negative 3. and C is given as t, 11, and 12. So first, find the equation, and the vector equation of a line that goes through A and B, and 2, find the value of t such that C is also on the line. I hope you enjoyed this video and try some questions in this section to really master the skills that we have learned. Anyways, I'll see you in the next video. Best wishes.